Good morning. Today in this video we will study grouping of capacitor. Okay, in an electrical circuit, capacitor is represented by this symbol. Okay, see, battery is represented like this. Once two lines, but one is shorter lines. But capacitor is represented by two parallel lines of equal length. Okay, and this C is the capacitance of the capacitor. We can arrange or group capacitor in two ways. One is series combination and the other is parallel combination. Series means when several capacitors are connected in a series combination, the reciprocal of the equivalent capacitor is the sum of the reciprocal of the individual capacitance. Series combination means let's say there are three capacitors C1, okay, C1, C2 and C3. Okay, so series combination of these three capacitors will be like this. That means they are connected one after another in series. C1, so this is C1, C2, C2, C3, C3. That means C1, C2 and C3 are connected in series one after another. So let's say this is the battery. Again, this type of combination is called series combination. Okay, here the capacitor, this capacitor, these three capacitor with their corresponding capacitance. This is the capacitance. So these three capacitors are connected in series. So in that case, the equivalent capacitance of the three capacitor will be, according to this definition, when several capacitors are connected in a series combination, the reciprocal of the equivalent capacitance means the ratio. Let C be the, if C is the equivalent capacitance, of C1, C2 and C3, then according to this definition, when several capacitors are connected in a series, that means they are connected in a series. Several capacitor means this one capacitor, two capacitors. So in this case, there are three capacitors are connected in a series combination. The reciprocal of the equivalent capacitance. So reciprocal means 1 by C. So the reciprocal of equivalent capacitance is equal to the reciprocal of the equivalent capacitance is equal to the sum of the reciprocal of the individual capacitance. So this is equal to sum of the reciprocal of the individual capacitance. So here the individual capacitance are C1, C2 and C3. We have to add up. Sum means addition. We have to add the reciprocal capacitance of C1, C2 and C3. That means 1 by C1 plus 1 by C2 plus 1 by C3. So this is the formula for the equivalent capacitance when the capacitor are connected in series. This C is the equivalent capacitance. Okay, that means in place of this C1, C2, C3, we can directly write we can replace by this C. Okay, this C, because this is the equivalent capacitance of C1, C2 and C3. An example. Okay, this is battery. Suppose that the battery has 10 volt. Okay, let's connect three capacitor in series. So 1, 2, 3. So these are the three capacitor. Okay, so let's say C1 is 10 farad. Means F is the unit of capacitor. It is farad. F-A-R-A-D, 10 farad. Okay, number one is C1 is 10 farad. Let's say C2, let's say it is 5 farad. And let's say C3 equal to 10 farad. Okay, now we have to find the equivalent capacitance of these three capacitor which are connected in series. Now we know the formula. The equivalent capacitance is given by 1 by C equal to 1 by C1 plus 1 by C2. See, if we have only C1 and C2, then we have to write only this much, okay, till C2. Yeah, but we have three capacitor, so 1 by C3. If we have another capacitor C4, then we have to make 1 by C4 like this. Okay, but here we have only three capacitor. Now put the value. 1 by C equal to C1 is 10. 1 by 10 plus C2 is 5. 1 by 5 plus C3 is also 10. So what is the LCM of these three? So 10, 5, 10, 5, 10. LCM is 5, 2 jar 10, 5 1 jar 5, 5 2 jar 10, 2 1 1 1. It is 10, right? So it is 10. So here we'll get 1 plus 1 by 5 into 10 is 5 in first one 1 by 10 1 by 10 into LCM is 10, so we are getting 1 so 1 plus second one is 1 by 5 into LCM 10, 5 1 jar 5, 5 2 jar 10, so it is 2 plus 1 same 2 3 4 4 by 10, so we are getting 4 by 10 so here 1 by C equal to 4 by 10. Now this C is in downside so if you arrange, then we will get 10 equal to 4C we need C, right? So from here 10 by 4 equal to C, right? So 4 1 jar 4, 4 2 jar 8, 4 2 jar 8, 9 10, 5 4 jar 2.5, I think 2.5, right? 2.5 4 1 jar 4, 4 2 jar 8, 9 10 point 4 5 jar 20, yes 2.5. So the equivalent capacitance of C1, C2 and C3 is 2.5. So that means we can replace these three capacitor na C1, C2, C3 with single capacitance C na 2.5. So this C equal to 2.5 farad, 10 volt. So these two are equivalent, same. Okay, instead of representing with three capacitance, we can represent it with only one capacitor, nah? But both of them will give the same circuit only. Okay,